Everyone, this is Rajesh. In the last video, we have seen how to write a simple program for ARM microcontroller development board, that is Freedom Development Board. And in that program, we haven't seen how to debug the program by using Keil Macrovision to debug the Freedom Development Board. In this video, I am now showing you how to use the Freedom Development Board with connected with PC and how to debug that using Keil Macrovision. Here I am showing you the KL25Z development board. So this is the KL25Z development board, and you can see this is the processor. This is ARM Cortex M0 Plus processor, and you can see this is the LED, so RGB LED. This this RGB LED is connected to the ports, port B and port D. Red LED and green LED are connected to port B 18 and 19th pin, and blue LED is connected to port B first pin. So these are the USB ports, and this you can get the USB cables for which are compatible, and these cables can be bought from the low range mobiles. So, and this is the cable used for this one. So you can see the pin how the cable is here, and one end of the cable is the USB cable. So with this I am going to plug in. So first, this Freedom Development Board is to be used with this pin, that is called SDA. You have to plug into the USB at the SDA port. So here we have two USB ports. Here we have to use this USB port when you want to debug it by using Keil Macrovision software. So this is SDA code. This is called Software Debug Adapter. So that SDA code is to be used for debugging the KL25Z board by using Macrovision. Now, so whenever I plug this into the PC, so you can see that you can observe the light that is being lit here. So light has been lit. So as soon as you plug in your device for the very first time, you are going to get a removable disk like such thing. So now here you can observe I am not getting anything here. So I have only CVD EF drives. So because my this board has been programmed for a number of times, this is not visible as a removable drive. So to make it visible as a removable drive or to reset the state of this development board, we have to press and hold the reset button while plugging in the USB as I am showing it now. So this is the reset button. Between two USB ports we have the reset button. So by removing this cable, I have taken out this cable, and now I am pressing and holding this button like this. So while it was press and hold, we have to insert this USB cable so that we will get this LED to be blinking like this. So this shows that your board is connected to PC and it is showing one removable USB drive. So it is not just sufficient to connect your board and debug it by using software Keil Macrovision. We have to do some arrangements before you can dump your program into your microcontroller development board. So prior to that, I am going to show you how to do that thing. So first of all, we have to enable these two statements because we have disabled these two statements because you are in simulator mode. So now to use this with software debug adapter for this Keil Macrovision development, sorry KL25 development board, we have to re-enable these statements by clicking uncomment section. So now we have uncommented this one, so this will execute and this will execute and this will also execute. I am going to rebuild this one, and the very next thing we have to do is we have to go to this pack installer. So select on pack installer and select our semiconductor board, that is Freescale board, KL KL2X and MKL25Z 128 port. So now after clicking this one, we have to go to this section, example section. So there is a CMC's RTOS Blinky Freedom KL25Z library. Now we have to copy this one. So we can store this at any location we want. So now I am going to store it in the folder example 1. Select folder and click on OK. So this will be copied. Now we have to close this one and go to our. So if you can see here that it is now bootloader.h drive. So it is now a removable USB drive, and you can see here also. So this has become a removable USB drive. Now we have to go to our documents and the folder where we have created our project. Here you can see the boards. It is now created. Boards, Freescale, Freedom, Blinky, OpenSDL. Now copy this file. After copying this file, we have to store that file in this removable drive. So I am pasting it here. So this will disappear now. So this drive is going to disappear now. After removing the USB cable and again plugging in, this will get disappeared. Now you can observe again. Now I have taken the USB cable out. Again I am going to plug in into this PC. You can see this green light till now which was blinking, that will not have any blinking now. So it has got only one time blink and it stopped. So now we can say that so there is no USB removable drive in this section. So that means we have copied it correctly. Now we can dump our program into this Freedom development board. So to dump the program, first of all we need to set the hardware debugging options. To set the hardware debugging options, we have to go to this options for target and select on debug. So till now we were in the simulator mode, so we selected use simulator. Now we are going to use this Freedom development board to be connected with the PC. So we are now using this hardware debugging mode. So here we have several categories, and what we have done is we have copied the CMSIS related file into the bootable removable drive. You can observe here. So it is CMSIS DAP. So this has been copied to the bootloader USB drive which has been present earlier when the board was in reset condition. So now we have to select this CMSIS DAP debugger and click on settings. You will be getting this enabled. So if you are not getting this enabled, then there might be some problem with your software. After this, click on OK and utilities. In utilities, we have to select, we have to uncheck this use debug driver, and we have to again select here CMSIS DAP debugger and click on OK. So now we have to rebuild our solution, and now we are going to use this option download code to flash memory. Now we are going to download code, and you can see the status in this region. How the program is going to be programmed under the flash memory. The status of the program you can see in the down status bar. So it has got finished. Here you can see the flash finished at so and so time. Now we can use this program to debug our microcontroller development code. Now go to debugging. So it is in evaluation mode. So the maximum code limit is 32K. You can write program so which will not exceed 32 kilobytes of memory. So now when you are going to into the debugging mode with the help of this Freedom development board, you can see the LED again it is going to be in active state. So you can see here, so LED is in active state now. Now we can easily debug the program that is being dumped into this microcontroller development board. Now I am going to I have disabled these statements because this is to be needed, because this will check the system clock whether it is installed or not and how much is the frequency of the system clock that is installed in the development board. Now we are going into step by step debugging mode. Now I am clicking on this one step. So again, so it has loaded or not with the system initialization address, and this will branch the control to go to this address, that is the address present in the register or not. So you can see the contents of PC 104, contents of or not 105. Earlier it was something different. Now it has gone to the system initialization. Anyway, it will see the clock whether it is installed in the development board or not, and it will successfully come out if it was installed. If it is not installed, it will not come out. So this development board is equipped with a system core clock, so it will successfully come out. So there is no need to bother about execution of this program. So I am going to step out of this current function. So it will directly come to this location. And again I am loading or not is equal to main. So now my PC is at a location C6, or not is carrying the location FT. Now PC is to be changed to FT or FE or FF in and around this location. Okay. So now we haven't seen the changes that is going to take place in the register. Again we are going to reset it. So we have to create a breakpoint here. So after creating breakpoint, the execution may come to a stop position at this point. Now again I am going to run this, come out of this section. So it is saying that this target device does not support all the defined breakpoints. Please reduce the number of breakpoints and start again. So we have to reduce the number of breakpoints that we are used here. So I will simply go to this section and I will select this. So again it is showing that reduce the number of breakpoints. So what I do is I will remove the breakpoint here, and I will go to the program and I will click here, LDR or not is equal to main. I will select this option, run to the cursor line. So because the cursor is blinking at this line, the control will directly come to this line after executing all these steps in between. So now the control has come to this line. Now I can set a breakpoint here, and I can select on run, so that this will stop at the defined breakpoint, that is the control will stop executing at this location. Now you can see here we have the arrow mark. Sorry, you are not having any arrow mark here. So now the yellow color arrow mark should come here after clicking on this option. So you can see here now the program is going to be executed from this point. You can see the changes. So R1 is equal to 21 and R2 is equal to 15, and it has come to the last position exit. So this is how we are going to work on the Freedom development board, and we can stop debugging now. Okay, so thank you for watching. This is the end of our tutorial. So we will see the rest of the things in the next tutorial. Thank you.